All right, welcome back. We are going to finish up our first lesson on probability, introducing probability. And like I said, we're going to start off this with the exercises from the previous two examples. So go ahead and pause your screen, read through these questions carefully, answer them, and when you're ready, press play so that you can see the results. All right. I put the answers in fraction form, but again, you can put them in decimal form or percent form as long as they're correct. So make sure you're making your conversions from fractions to decimals to percents correctly, and it's all good. I'll have the answer keys set up for all of that. All right, so now let's move on to the next topic. Remember before I mentioned that we were going to be talking about odds. And odds is another measurement of likelihood that an event will occur, but it's not the same thing as probability. And the reason why is look at the two formulas we're using. Odds in favor of an event. When we talk about the probability of an event occurring, we always look at the favorable odds, the favorable outcomes. So odds in favor of an event are pretty similar, where the numerator is the number of favorable outcomes, but the denominator is the number of unfavorable outcomes, so the things we don't want to happen. The odds against an event occurring, so against, what are the chances it's not going to happen? That would be the number of unfavorable outcomes, meaning the opposite of favorable, over the number of favorable outcomes. Odds are ratios. So very similar to a fraction in properties, but they are technically ratios, the numerator compared to the denominator. So we write our answer as a ratio. The most common way of writing it is using the colon, so the ratio of A to B, but you can also see it written as A to B or in fraction form. But if you see a word problem that has the odds given to you, you'll most likely see it in either the using the colon or using the words A to B. So just be on the lookout for that. Okay? Moving on to our first example. We're going to have to move the screen up just to see the questions. A high school has 2 fall sports teams for boys and 2 fall sports teams for girls. Sounds pretty similar to what we have here at KIS. The number of players on each team is listed in the table below. One student participating in fall sports is randomly chosen to represent the school at a town forum on high school sports. For those of you not familiar with the word forum, it's a vocabulary word. Town forum means kind of like a town meeting. It's a discussion to, in a public setting to have a discussion or a debate or something like that. So here's our table. We have the sport, we have the players. So football, field hockey, girls soccer, and boys soccer. Football is traditionally considered a boys' sport, and field hockey is traditionally considered a girls' sport. That's the 2 girls and 2 boys teams listed. I don't know, I've heard of some girls getting a chance to play football. Usually, if they're the kicker, they're not the ones out there tackling, anything like that. Field hockey, I don't know, I've never really seen a lot of boys playing. Lacrosse tends to be a more popular sport that's like field hockey, but a bit more violent. So, the boys can be happy beating up other people. Alrighty, so let's talk about finding the odds in favor of these events and against these events. I need to move the screen up so we can see the rest of the questions. There we go. Come back over here. Okay, so the first question says, find the odds in favor of a field hockey player being chosen. So again, the odds in favor would be the favorable outcomes, so 24 of those, over the total number of unfavorable outcomes. So we have to add up the other unfavorable outcomes. So 39 plus 18 plus 18 again. And that gives us 75. All right, 24 over 75, that can be simplified to 8 over 25. So the odds in favor of a field hockey player being chosen is 8 to 25. Right? Again, not good odds. While we're not really looking at this in the terms of a fraction, so we're not looking at 1/2 versus another, we are looking to see which side has the bigger number. And the favorable outcomes is smaller than the unfavorable outcomes. So the likelihood of the event happening is not necessarily favorable for us, right? It's more unlikely that another sport will be chosen other than field hockey. All right, let me erase that for just a second. Move on to our next question. Find the odds against a football player being chosen. So finding the odds against a football player being chosen. So the unfavorable would be all of the other people besides the football player. So we would have 24 plus 18 plus 18. So again, these are all the unfavorable outcomes. If one of those people is chosen, that is not a football player. And then 39 would be the number of favorable outcomes, the football player. So again, we need to simplify this. Let's divide by 3, and we end up with 20 over 13. So the odds against the football player being chosen are 20 to 13. So pretty good odds that a football player will not be chosen, since there are more unfavorable outcomes, meaning more non-football players out there, than there are football players. All right, and now find the odds in favor of a soccer player being chosen. Now notice it just says soccer player. It doesn't say if it's a boys soccer player or a girls soccer player. So this time, talking about odds in favor, so our numerator, of course, is going to be the favorable outcomes, the soccer player outcomes. And we have 36 favorable outcomes, 18 boys, 18 girls. So that gives us some pretty good chances here. And then the unfavorable outcomes would be the other ones. So 39 plus 24 gives us 63. All right, so 36 to 63. Again, let's simplify. Divide by 3, we get 12 over 21. That can divide by 3 again. So that would be 4 over 7. So the odds in favor are 4 to 7. The closer you have of equally valued numbers to each other, like 4 to 5 or 4 to 4, or 4 to 4 would be 1 to 1 odds. That means if it's the ratio of 1 to 1, right, that means it could go either way. So then you have to look at which side has the higher numbers to determine the likelihood of the event happening or not happening. So a little bit different from probability, because the denominator is always going to be the opposite of what you had. So whatever outcomes went in the numerator, the opposite is your denominator. So that's the big change there. And for most students, that's going to be kind of the make or break when it comes to this, remembering those formulas. Can you remember the formula for probability compared to the formulas for finding the odds in favor or against an event? All right, let's move on to our exercise. Just kidding. Let's try it again. Mouse. There we go. Now let's look up. Okay. So pause here, take a moment to read this word problem. It's a little bit lengthy. You might have to read through it a couple of times. Just like I always recommend with word problems, read through it a couple of times, write down the important information, and then answer the 2 questions. So press pause, solve the problems, and when you're ready, hit play to see the answers. All right, so here are the 2 answers for the questions regarding odds. And again, I put the answer using semicolons. You could write the answer using the word to, or putting it in fraction form. Reason why I like to do it using the semicolon versus putting it in fraction form is that it reminds me that these are odds, whereas if I see something in fraction form, if I don't know the context of the question, meaning I don't know you were asking for odds or being asked for odds against something, I might think this is probability. Since probability tends to be more commonly written using fractions, decimals, and percents, writing odds in a ratio form using the semicolon, it's just a little bit easier for you. It's not necessarily a requirement because 1/19 is a way of writing a ratio, but it makes it a little bit easier for you if you're consistent using one way for probability and another way for odds, just to limit the confusion here. All right, so that's the end of the introduction. We'll move on to our in-class exercises.